All right, we're back. So number 15, again, we're going to be using Desmos as we go here and see is it a one-sided limit or a two-sided limit. So let's go back here, and I'm just going to go from Desmos and show you what it would look like off the graph. So we have the absolute value of x minus 5, and then in the denominator x by 5, and say what's happening at 5. So as the function approaches 5, what's the y value there? So this one has it from the left. So from the left, what's the y coordinate? And can you see from the left the y coordinate is -1? And there's your answer. The next one is the square root of x subtract 1 over x subtract 1. And I want to know what's the limit as x approaches +1, and is it a two-sided limit or does it exist at all? So if I plug in 1, what's the y coordinate as we go here? So as you plug in 1, I want you to notice at 1 it's undefined. But what's the y coordinate from the left and from the right? And look at the scale, and I want you to see that with that scale, the y coordinate there as it's approaching is 1/2. And you can see that in the decimals there. And the right and the left agree what the y coordinate is there. This one's going to be piecewise. So the top, I'm going to type in f at x. Actually, the piecewise I'm just going to plug in. So what's the value of -2, and does it agree top and bottom? So let me just show you that one. I don't need to see this one off the graph. I can substitute in. So the top is going to give me an answer of -1. When I plug -2 into the bottom, I get +4, take away 1. So this gives me the answer -1. This gives me the answer +3. It says it's a two-sided limit. Do they agree top and bottom what the answer is? And the answer is they don't agree. So one gives me the answer -1, the other gives me the answer 3, so therefore the limit doesn't exist. If you had a little minus sign, it would be -1. If you had a little plus sign, it would have been +3. Number 18. So the limit is from the left side. So see that little minus sign there from the left, or is that a plus sign? Oh, it is a plus sign, right? So for a plus sign, we're looking from the, it is a plus sign. Font size really small. So from the right, we're looking at the bottom when it's greater than -3. All right, plug it into the bottom only. So negative and a negative. Be careful. That's +3. Take away 3. That answer is 0. By the way, the top would have given you the same answer too. So if I would have looked at it, so the two-sided limit is equal to the one-sided limit. Okay. Here, I'm going to need a graph. The rest are trig functions, and I'm just going to graph those. So let me go to the graph again, and I'm just going to type them in, look at it, and do our best, okay? So cotangent 2x. Make sure I know where I'm looking at. So I'm looking at 0. So at 0, what's happening to the left? And can you see it's going down forever? So the answer is -infinity. The next one is -2 cosecant. So -2 cosecant 2x. And I'm looking at when x is approaching pi. So I'm going to change the scale. And I'm just going to change it to pi over 2. I could change actually to pi and see it too as well. So if I just typed in pi for my scale and go back, what's happening at pi? So it says it's a double-sided limit. So I'm looking left and right. So at pi, the left side's going up, the right side is going down. Therefore, it does not exist because they don't agree. And it's a two-sided limit we're looking at. Sine x, just the wave. Here we are. So sine x, just the wave. And it says pi over 4. What's the answer? So this will give me a decimal, right? Now, I can see there's a value there. So let's write this as a function. And then I can just type in pi over 4. So what's the value of pi over 4? And it's 0.707. That's good enough for me. Next, 22. 1 over and in the denominator, tangent x, subtract 1. So what's happening at pi over 4? So I want you to notice at pi over 4, and I should just change the scale so you can see it better. So I'm going to change this scale to pi over 4 so you can see what's happening at pi over 4. Did it change it to pi over 4? Yeah. So each square is pi over 4. That's what gets us to pi. So right here is 1/4 pi over 4. So to the right, it's going up. To the left, it's going down. And there's a little plus sign. So to the right, it's going to infinity. So because it's a one-side limit with a little plus sign, the right side is going up forever. 23. 2 left. The limit as x approaches pi over 6, and it's secant squared x subtract 3. Just like that. And what's happening at pi over 6? So let's change the scale. I'm going to change this to pi over 6. Didn't do it. Here, let's see if it'll do it. So what's happening at pi over 6? And can I just do a substitution actually? So when I look here, I have a sense of where pi over 6 is. It's actually pretty close to 1/2. But I'm just going to see if I can just do a direct substitution. So I'm going to write this as a function. For some reason, the scale didn't change the way I wanted to. I wanted the scale to go pi over 6, and it didn't. So I'm going to do it a different way then. So we have pi over 6. And we actually do have a value. That's negative 1.666. If I want that to look like a fraction, that's what it looks like. Isn't that a fun little button there? So it's negative 5/3. And there's your answer. All right, last one. Sine x subtract 1. Over x. And so I'm looking for as x approaches 0. So when you look at 0, the left is going up forever, the right is going down forever. So therefore, it does not exist for a two-sided limit because the left side and the right side do not agree. So let's see if you have the answers from 15 on. So here are the answers from 15, 16, 17, 18, all the way to 24. And that's it. That's the lesson for today. So again, what's the lesson? Is that limits could be one-sided. It could be the left side you're looking for or the right side. Either way, you're looking for the y-coordinate when you're looking there. And so we looked off the graph, and we saw sometimes it exists, sometimes it doesn't. It goes to infinity or negative infinity. But we're looking at where the y value is or where it's going and putting our answer down. So there's our lesson. Now we're going to do some more practice on one-sided limits. And we'll go from there. Mr. G Math. Over and out. I'm proud of you, and until next time.